IVT, intermediate value theorem. Of course, it's for continuous functions. If the function is not continuous, we cannot apply the intermediate value theorem. So here is the application of it directly. And here's my question. I graphed a function. Is this function continuous on this interval a comma b? I don't care what it does outside. Can I say that f is continuous on a comma b? Can I say that?
Yes.
Yes. It doesn't have a jump. It doesn't have a removable discontinuity. It doesn't have an infinite discontinuity. It's continuous. According to the way I graph the function, can you agree with me that f of a is a negative number and f of b is a positive number? Would you agree with those? Take a moment and see if you agree. Do we?
I think that's right.
Sure. F of a is here. It's a negative number. F of b is here. Is a positive number. Yes, I could have graphed the function like this. Then I would have said f of a is positive and f of b is negative. I chose to graph it like this. It doesn't matter. There are only two options. Either coming from negative to positive or coming from positive to negative. Then by IVT, there exists a number C. And this is the symbol that I always like to use. If you don't like to use it, just write in. There exists a C. I will find a C in the open interval a comma b such that what? What do you think? The function is continuous and it changes sign from negative to positive. What has to exist? Because it's continuous. If it's not continuous, this fails.
A zero?
Of course. Such that f of c is 0. Here it is. At least one. The function can do all this, but I'm talking about one interval, right? So then I have to narrow the interval to show just one. So that f of a is negative, f of b is positive. The function cannot jump over 0. It's continuous. So if it comes from negative, it has to cross, it has to have an intercept, because otherwise it will not go positive. Or if it's coming from above, it has to cross. Otherwise, it will never go negative. But it has to because it's continuous. So then, if the function is continuous and it changes sign on the interval, it doesn't matter from positive to negative or from negative to positive or from positive to negative. It doesn't matter. It changes sign. Then by IVT, I will find a C in the open interval a comma b, not the closed interval, but the open interval, such that f of c must be 0. So c is a 0 of the function, or c is the x-intercept, or one of them of the function. There must be. Does the intermediate value theorem tell us what c is? No. It only tells us that a c exists. It does not tell us where it is. It does not find it for us. But this is tremendously helpful for chapter 4, in which we will be able, based on this, we will be able to solve any equation you can think of. So the intermediate value theorem says, look for it over there. There is a solution. Normally, we like this interval to be 1 unit. Not between 1 and 15, no. Between 1 and 2, or between 2 and 3, or between -5 and -4, or between 0 and 1, but not big, not more than 1 unit. We can always narrow it down, so we keep it as 1 unit interval. Okay, so we're ready to start with the simple example, and that's the IVT. And let me show an example. Let's say we want, that's problem 10, page 10. Let's say we want to look at natural log x equals 3 minus 2x. And the question is asking us to find an interval, analyze this function. Does it have a c? Does it cross the x-axis? Can I solve this? The answer is no, I can't solve this, but at least find an interval. 1 unit interval where a solution to this equation exists. Find an interval. Can you find a solution? No, you are not. We're not equipped yet. Not for something like this. We're not equipped to solve this equation algebraically. No one is. We have a method that we will discuss later. But we're not asked to find a solution. So no, we're not asked to solve. We're asked to find an interval where a solution might exist. Okay, fine. My first step here has to be find a function. What function? Well, we're talking about this equation. I will move everything to one side. Natural log x plus 2x minus 3 equals 0. Solving this equation or solving this equation makes no difference. But I have my function now. So the function that I will be using is natural log x plus 2x minus 3. Awesome. Number 2. Notice that this is defined everywhere. This is just a poor constant. But what about the domain of this function? And we graphed it today. That's why we graphed it, so we can remember where it's going, its limits, its domain, the whole spiel. So can anyone tell us the domain of natural log x? We don't have to think. We just have to
0 to infinity.
Excellent. So remember, there is no way we will look for an interval anywhere else but somewhere between 0 and infinity. Don't dream of -4, -3. It's not going to work. The domain of this function, although this is all real numbers, this is the restriction. Okay. In step number 2, after we establish the domain, so let me write the domain here. Right, this is it. 0 to infinity. Everyone understands why? Don't let me move on if you have any doubts. Everyone understands why?
Yeah.
Okay, let me know. Okay. Now in number 3, we plug in. And you can say, plug in what? I don't know. I'm going to share my screen. I'm going to go to the calculator. I am going to go to y equals, clear whatever, and put in my function. My function is natural log x, and then plus 2x, and minus 3. Make sure you have second and table. Go to table set first. Make sure that you're independent. Only independent is in the ask mode. And then after you establish that, or make sure you get that, then we go to second and table. And I'm going to punch in. what? I can't start at 0, so I'm going to punch in 1. I'm going to punch in 2. Yay! I found an interval where the function changes sign. At 1 is negative and at 2 is positive. I don't care about which numbers. I only need to show that f of 1 is negative and f of 2 is positive. That's sufficient. Why? Because the function is continuous. I have to write that down. First, f of x is continuous on 0 to infinity. And I found that at f of 1, I don't care to even write the number. It's a waste of time. And at f of 2 is greater than 0. Continuous changes sign. Then by IVT, there must exist a C. I didn't mean that. C in the open interval 1, 2 such that f of C is 0. That's all we were asked to do. We were not asked to determine because we cannot. Yes, the calculator can give it to us, but algebraically we cannot do this. So we were only asked to find an interval. Can I find more than one interval? Yeah, but I don't care. We were asked to find one. Find an interval of 1 unit length, in this case from 1 to 2, whereas since the function is continuous, it changes sign. Therefore, there must be a C in the open interval 1, 2, such that that is the x-intercept, a number between 1 and 2, because f of C equals 0. Is this okay? Do we understand this mechanism?
Yeah.
So this is the IVT. Please remember it because we're going to need it again in chapter 4.
So I'm just trying to get this right. So we're just plugging in the function and then like giving it some values and seeing where it changes.
Yes, yes. But remember, you have to establish a domain first because you don't know where to start. And you don't want to be all over the place and getting error, error, error.
So I put on my calculator and all the values I'm getting are all negative. Could you show me where you inserted it again into the calculator, please?
Yes, of course.
Thank you.
Does it work now?
No. It's just all negative. Maybe
So just erase everything and just start from scratch with natural log x right here. Put the left. Did you put parentheses? You have to close the parenthesis here. If you didn't close the parenthesis here, then you get something else.
There's parentheses. Yeah, it looks exactly the same.
Okay, so plus 2x minus 3.
Mm-hmm.
Did you use the correct minus? It's this, not this.
Oh, okay, maybe that's why. I'll switch it.
Just make sure that you use that. And I'm plugging in my device here. Is that better?
Yeah, that's better. Thank you. You got fixed.
Okay, good. What was I going to say next? Yeah. Would you like to upload this so I can see it? You don't have to use the symbols. So one more time, by IVT, just this page, one page, just this page. So by IVT, you can write in words, I will find C in the open interval 1, 2, such that f of C equals 0. You do not have to use the symbols. I'm not testing you on symbols. Just write it in words. This is a very powerful theorem, and it's based on continuity. If the function is not continuous, we cannot apply this theorem.
I'm sorry, can you give the explanation to the symbols again?
Yes. So we had that last time also, but I wrote it here too. So for any or all there exists, I will find this is such that, and this is in. Okay? Is this good enough?
Yes, that's okay.
Okay. Good. So now I would like to talk about a problem. Should I wait? Do I need to wait?
Yes, please. Just about a minute.
Very good.
Thank you.
Thank you. I'll get more water then. Okay.